Hi everyone! Today's video will be all about simply supported beams, how to calculate reactions, how to draw a shear and moment diagram, and at the end I will be sharing a free online tool which will help you verify your work. Also, I have put together a free PDF guide with some basic information about shear moment diagram, what to look out for, along with a few practice problems I have collected from various FE material. So we have here a simply supported beam with a uniformly distributed load and a point load. So in order to draw the shear moment diagram, we will go ahead and solve for the reactions. Let's name this point A, and then in here we're going to B. This is going to be VA, and then here it's going to be VB. So in order to calculate the reactions, we are going to do sum of moments in point A equals 0, sum of moments in point B equals 0, and then we will verify our reactions by doing a sum of forces in Y direction. And once you calculate all that, you get VB equals to 6.75 kilonewtons. All right, now let's go ahead and do sum of moments in point B. Now sum of forces in Y direction equals 0. We're doing this just to verify that our reactions have been calculated correctly. So we'll have VA, which is 525, plus VB, which is 675, minus 3, minus 3 times 3, 9. So we have 12 minus 12 equals 0, which is true. That means we have calculated our reactions correctly. Now let's go ahead and draw our shear moment diagram. We'll start with the shear. We start at 0 and we go up with VA, which is, let me see if I can write the VA value here, 525, and VB value I will write it up here, 675. So once starting at 0 we go up. You can see our VA goes up, and the value of that is 525. Now from here, in this first section of ours, we have a uniformly distributed load, which means our diagram will look linear. And let's see how much do we have to go down, because our load points down. We're gonna go down 9 kilonewtons. So from 525, we're gonna go down 9 kilonewtons, which means I'm gonna have here a value of 375, and we draw, there you go. It will look something like that. Positive on the top here and negative at the bottom. And now from here, from 3.75, now when I'm looking at the next section, I don't have any loads, which means my diagram will look constant. So we just go ahead and draw a straight line for this section. We are in the negative. And this value is also 375. So now from 375, at this section here, I'm looking at the force. I have VB, the reaction VB going up, goes up 675, which means I will be having all the way up here 3 kilonewtons. We'll have 3 plus 375 equals 675. So from this point, I'm looking at the next section. I have a point load at the end, but the section doesn't have any other load, which means I will my diagram will look constant. So I'm going with 3 constant all the way till I reach the end of the beam. And in this point, I have to go down 3 kilonewtons, which is exactly how much I need to get back to 0. And it's important for us to get back to 0. This is one way of knowing that we drew our diagram correctly. If you don't get to 0, it means you've done something wrong, so you have to go back and check yourself. Verify your work. Now this is 3, perfect. Now let's go ahead and draw the moment diagram. Now in order for me to draw the moment diagram, I need to calculate the areas of the shear diagram. So in this first triangle here, we don't know this distance in order to calculate the area. So we will have to calculate this distance. Let's call it out X. Hopefully you're able to see this. So let's calculate our X. We will calculate this X out of these 2 similar triangles. This is my X, and this is my value here, which is 525. And then my other triangle is, I have 3 here, and the other value here I have 9. So this is this bigger triangle over here, and this is right. We have 525 plus 375, which is 9, and it goes over the entire length of this section, which is 3. So my equation is going to look like this: 525. I meant 525. I will be going. There you go. 525 relates to 9. The same way X relates to 3. This means that X equals to 525 times 3 divided by 9. By 9. Which means if you do the math, our X equals 1.75 meters, which means the other side right here is 125. So area number 1 is 525 times 175 divided by 2, and you get 4.6 by doing the math. $4.6. The area number 2 is 375 times 125 divided by 2, and you get 234 after doing the math. 234. Area number 3 is 375 times the length of the section is 3, which makes it 11.25. And number 4, 3 times 3, we got 9. Now let's start and draw the moment diagram. Again, we start at 0 because we don't have a moment at the support. The moment at the support is 0. So I'll go up a little bit so we can see the perfect. So starting at 0, we look at the shear diagram here. It's positive. That means we're going to go on the positive side of the moment here. And also, what I forgot to tell you guys is here at this spot where this diagram intersects this horizontal line, we're going to have to draw another straight line down. This is a place of minimum or max. So we have to draw this line. Perfect. So now we can continue. Starting at 0, going towards the positive side of the diagram, 4.6. And another thing we know is since this is linear, our diagram will look parabolic. Now, it is always a big question, which way do you draw your diagram? Is it gonna look like this or like this, right? So I've heard somebody explaining this very beautifully. Let me quickly draw this. This is my shear diagram, and the simplest way somebody explained it, and I thought it makes sense. Let's think about it as we have a big value here, and it goes towards a smaller value, right? So if you think about it as a skiing slope, think as if you're going fast, and then you go slow, right? You go fast and then you go slow. So the same way you're going to draw, having this in mind, draw your diagram like this, fast and then slow. And then when you have your diagram, your shear diagram the other way around, slow and then fast. So starting here, your diagram will look like this, slow and then goes fast. So let's try and do that. So in my case, I'm going fast and then slow. So starting at this point, I'm gonna go towards the positive direction, positive side of the moment diagram, and the value here is going to be 4.6. Okay, I'm gonna make it bigger like this. So I'm going to go fast and then slow. And this is positive, is on the positive side, because my diagram here, the shear diagram, is positive. Now, moving forward on the next section here, we have the area of this triangle is 234, which means 4.6 minus 234. It's gonna land me at 226, still here on the positive direction, 226. And look at the triangle, it goes from a small value here to a bigger value, which means, again, thinking of that slope, you're gonna go slow and then fast, which this is the way it's gonna look. We're going slow and then we're gonna go, wait a minute. We have to end up here. So slow and then fast. Okay. All right, so now from 226, I'm looking at the diagram again. On the next section, I have to go towards the negative side, and I have to go with 11.25. So from 226 minus 11.25, this will land me here at 226, 11.25 at roughly 8.99, which is approximately 9. So I'm gonna just write approximately 9. And my diagram will look linear since shear diagram is constant. My moment diagram is going to look linear. So I'm just going to go ahead and do that. Here we have a positive value, and here is our negative diagram. And from 9 on the next section, the next section, we have again a constant diagram, which means my moment diagram will look linear, and we have 9 here, and we're gonna go towards to this point. We're gonna end up exactly in this point because the value of the area of this shear diagram is 9, which is exactly what we want. This is exactly what you have to end up. You have to end up at 0. Otherwise, you didn't draw your diagram correctly. This looks a little bit messy, but I hope that makes sense to you. And if you have any questions, please ask. Okay, so now let's verify if we drew our diagram correctly. So we go to this online beam calculator. It's beamguru.com, and in here you can just build your beam with the loads and verify if you drew your diagram correctly. So let's go ahead and enter. Oh, I actually have it already done. Let me just delete this, and I will be doing this all over again, just so that I could show you exactly how it's done. I will be deleting the loads. Okay, so here we are. We have just the beam with no supports. We are working in meters and kilonewtons, so our units are correct. If you have pounds and kips, you just have to change these values here. I'll leave them like that. My beam length is 9 meters. I have support on the left, and then I have another one, a roller. Let's see, we have a roller 6 feet from the left, so we add that. Here is our roller here. Now let's move on and add the loads. We have a uniform load, 3 kilonewtons per meters. This is the load we've got. Starting location is at 0, and it goes all the way to 3 meters. And the load magnitude is 3 kilonewtons per meters, which means I have to add the value in negative, or you just can add 3, right? Your value, and then just add the direction going downwards. So here is our uniform load. Also, we have a point load all the way here at the end. So what we do, we go here at the point load location, it's at 9 feet. Load magnitude is 3 kilonewtons. Again, it's negative because it goes downwards. Load angle is 90 degrees. And I believe that's it. And here is our beam, exactly the way we had it. And now let's go ahead and calculate it and check our diagram. That's it for today. Don't forget, if you found this video helpful, please subscribe and give it a like. This helps people like you find me. Also, click the link below and download your free guide. I will see you next week.